Guys, we're going to derive a formula for the volume of a sphere now. We're going to work off our previous derivation of area that we previously derived. Okay, so what I've drawn in front of you is actually a sphere, not a circle. And it's on a x, y coordinate plane. Has a radius of r. And inside of that sphere, along the surface of it, we can draw all these little tiny circles. They're slices of area. So you're going to have a little dinky tiny circle, bigger circle, bigger circle, bigger circle, infinite of them all the way up to here, and infinite of them all the way down to here. This is minus r. This length is plus r. Okay? And so now we're going to take this area function and we're going to send it across here and integrate it, okay? And so the dV, the differential volume, is one of these circles related to r, okay, multiplied by the thickness of the circle in the x-plane, which we're going to call dx. Okay, so we're going to take the area, which is pi times y squared, and we're going to multiply that by dx. So now this is giving a volume of an infinitely thin disk. Okay, this being the infinitely thin part, this being the disk part. All right. So now that's giving us an infinitely small volume. We have to make that into a real volume. All right. So what we're going to do is we're going to integrate both sides. So we take the integral of the derivative of volume, and then we take the integral of pi times y squared dx, and we take this integral from minus r to plus r. So we're going to sum from this minus r spot, we're going to sum all those infinite disks all the way up to plus r, okay? So this is what we're going to do. This integral cancels the derivative, and we just get a whole volume over here. I'm going to bring us up here. So we're going to say the volume of this sphere is equal to, and I'm going to pull out my y squared. It doesn't work. I can't have a y in here with an x derivative, all right? So what we need to do is we got to get creative, and we can see that r squared is equal to x squared plus y squared, Pythagorean theorem. So x squared plus y squared is equal to r squared, okay? And then we got to solve that for y squared, and what we get is y squared is equal to r squared minus x squared. So now we have something that we can plug into this y squared part. So we're going to take the integral from minus r to positive r of pi times, instead of multiplying it by y squared, we're going to put it in terms of r and x, times r squared minus x squared dx. So now when we evaluate this integral, we got to take the antiderivative of these two terms here. Let's bring that down. We're going to take the antiderivative now from minus r to positive r, or from positive r to minus r. And what we're going to get is pi times the antiderivative of r squared would be r squared times x. The antiderivative of x squared would be would be 1/3 x cubed, so x cubed over 3. We can bring our pi out now. So it's going to equal pi times this evaluation from minus r to positive r. Let's go ahead and evaluate that right now. And so we're going to plug in positive r, so we get r squared times positive r minus positive r cubed over 3 minus, now we're going to plug in the minus r portion into the exact same thing, so r squared times minus r minus negative r cubed over 3. Okay, and so the minus and negative becomes a positive. This becomes a negative r cubed because of that. And so what we're going to end up with is pi times r cubed minus r cubed over 3 plus r cubed minus r cubed over 3. So anytime, and this is our total volume, anytime you have 2 of something, it's just 2 times that something. So what we got is pi times 2 times r cubed minus r cubed over 3. And if we find the common denominator between this, we're going to find it to be a 2. So we're going to end up with pi times 2 times 2 times r cubed over 3. So we have 3 of something minus 1 of something. So we end up with 2 of those somethings left. So pi times, all right, so 2 times 2 is 4. So what we end up with is 4 times pi times r cubed over 3. And that's the volume of a square of a sphere is 4/3 times pi r cubed. So you can see that we've got the equation for the volume of a circle, of a sphere, through calculus, not through trial and error. And that comes from our original derivation of area that I did in the last video. So we started with a proportion, which is C over D is equal to some number, which we don't care about. We call it pi. From that proportion, we derivate the area of the circle. And then from the area of the circle, we derivate the volume of a sphere, 4/3 pi r cubed. That comes from all this calculus. Okay, so now you guys should be fully in tuned for my spiral mathematics. Thank you.